The year was 1940, and the world was at war. In the United States, the demand for naval and cargo vessels was escalating as the Allies faced mounting pressure on the seas. Traditional shipbuilding methods, grounded in centuries of craft and experience, required 6 to 8 months to construct a single cargo ship. These methods had remained unchanged since before the American Revolution, relying on generations of skilled craftsmen and painstaking riveting techniques. Into this scene stepped Henry J. Kaiser, a 58-year-old construction magnate known for massive dam and highway projects, but with no background in shipbuilding. On December 27, 1940, Kaiser signed a contract with the United States Maritime Commission to build 30 cargo vessels for the British government within 2 years, a task many believed impossible for a man who had never laid a keel. Kaiser's unconventional approach immediately raised eyebrows. The Todd Bath Iron Works, a veteran shipbuilding company, partnered reluctantly with him, assuming their maritime experience would compensate for his lack of knowledge. Critics dismissed Kaiser as a naive outsider. However, his ignorance of traditional shipbuilding would soon prove to be his greatest strength. Instead of following centuries-old methods, Kaiser and his team began to rethink shipbuilding entirely. They rejected the slow, sequential construction process and looked beyond shipyards to other industries for inspiration. The answer lay in the rapidly advancing world of automobile manufacturing, where assembly lines turned out complex products with unprecedented speed and efficiency. This was the birth of an industrial revolution in shipbuilding, one that would transform not just how ships were built, but who could build them. Traditional skilled workers would no longer be the sole builders of America's naval lifelines. Instead, Kaiser envisioned thousands of untrained but rapidly trained workers mastering specific tasks, operating in a system where ships were assembled from prefabricated sections in parallel, not piece by piece. As this vision took root, skepticism remained strong among naval architects and shipbuilders. William Francis Gibbs, America's leading naval architect and designer of the Liberty ship plans, observed the new project with cautious interest. Yet even he could not deny the urgency of the moment, with Allied shipping losses mounting and the survival of Britain hanging in the balance. The math was clear. The Axis powers were sinking ships faster than Allied shipyards could replace them. At the production rates of the time, America faced a grim calculus of defeat at sea. Kaiser's willingness to challenge every assumption, to embrace untested techniques, and to mobilize an unskilled workforce was the United States' best hope for outpacing destruction with creation. In early 1941, just months before the U.S. entered the war, plans began for a new kind of shipyard on barren mudflats in Richmond, California. Kahn's vision was a shipyard designed not like a traditional maritime facility, but like a vast automobile factory, lined with parallel building ways, massive cranes, railroad tracks weaving between vast open spaces, and areas dedicated to prefabricating enormous ship sections. This was more than a shipyard. It was a symbol of a new era. It was where the future of industrial production, wartime logistics, and American ingenuity would converge. Kaiser's gamble was not just on steel and workers, but on a radical idea: that complex ships could be manufactured rapidly without tradition, by ordinary people empowered through training and organization. The stage was set for a revolution that would change the course of the war and the history of industry forever. As 1941 unfolded, Henry Kaiser's vision of revolutionizing shipbuilding moved beyond theory into concrete reality. The traditional world of ship construction, rooted in centuries of meticulous craftsmanship, was about to collide with the principles of mass production, pioneered by the automobile industry. Kaiser's chief engineer, Clay Bedford, had recently visited a Ford Motor Company plant in Detroit and witnessed firsthand the efficiency of assembly lines, building thousands of vehicles with prefabricated parts. Inspired, Bedford returned, convinced that ships, massive, complex, and traditionally built piece by piece over months, could be constructed following similar principles. Prefabrication of entire sections and components off the main assembly line meant multiple parts of a ship could be built simultaneously and then joined together rapidly. This was a direct challenge to the sequential, linear wisdom shipbuilders clung to. One of the most radical departures Kaiser's team proposed was to eliminate riveting, a method that had joined steel plates for over 3 centuries. Riveting was labor-intensive and slow. Each Liberty ship required nearly 1 million rivets. Instead, Kaiser championed electric arc welding. This technique, well proven in pipeline construction but untested at ship scale, promised faster, stronger, and more flexible bonding of steel sections. Maritime veterans and naval officials greeted this idea with apprehension. The British Navy forbade welding on warship hulls, fearing brittleness and failure. Vice Admiral Emory Land, chairman of the United States Maritime Commission, voiced concerns in private correspondence, questioning the reliability of hulls constructed so. Yet the relentless threat of German U-boats, sinking millions of tons of Allied shipping, pushed desperation to accept innovation. Construction of the Richmond shipyard began on empty mudflats in January 1941. Traditionalists scoffed at the chaotic-looking site, with its oversized cranes and sprawling prefabrication yards. John Riley, an experienced naval architect, observed that Kaiser seemed to violate every rule of efficient shipyard layout he had learned. Yet, paradoxically, Kaiser's design was perfectly suited for his goal: rapid assembly. Unlike conventional yards focused on sequential keel-to-deck construction, Richmond's layout resembled an automobile factory. 7 parallel building ways allowed multiple ships to be worked on simultaneously. Massive cranes, positioned every 100 feet, handled massive ship sections weighing up to 150 tons, while a network of railroad tracks transported these giant pieces around the yard. This new industrial architecture enabled parallel production. A ship's bow, stern, deck houses, engine rooms, and bulkheads could be fabricated at the same time in different parts of the yard. When the sections were complete, they were lifted and welded together on the building ways. The entire process compressed months of work into mere days. Despite initial skepticism from traditional shipbuilders and naval engineers, Kaiser's unorthodox techniques began demonstrating promise. In June 1941, the first Liberty ship hull was laid down, marking a new chapter not just for American shipyards, but for manufacturing worldwide. This was the dawn of a new industrial age where speed, scale, and innovation trumped centuries-old craft traditions, setting the stage for an unprecedented wartime production surge. The most revolutionary element at Kaiser's shipyards was not just the factory design or the welding techniques, it was the workforce. Traditionally, shipbuilding had been a strictly controlled craft, passed down through generations in maritime communities. Shipbuilders were skilled artisans who trained for years, some for a decade or more, mastering every facet of construction. Kaiser shattered those conventions by knocking down barriers to entry and recruiting a radically different labor pool. In the summer of 1941, advertisements appeared across the United States, offering jobs at Richmond shipyards, with wages 20% higher than average industrial rates, and promising complete training for anyone willing to work. The call was answered by thousands of people from wildly diverse backgrounds: former secretaries, farmers, housewives, and laborers with no prior maritime experience. They formed a workforce unlike anything the maritime industry had ever seen. Kaiser's training programs focused on specialization rather than mastery. Instead of learning the entire shipbuilding process, workers were taught specific tasks: how to weld vertical seams, how to fit bulkheads, or how to handle curved hull plates. This focused training took just 2 weeks on average, a fraction of the years required in traditional apprenticeships. Even the most complex roles, such as crane operators and ship fitters, required only 4 to 6 weeks of preparation. This task-specific training enabled unskilled men and women to become proficient welders and fabricators rapidly. The labor force was a social experiment as much as an industrial one, with women comprising 27% of Richmond's workforce by mid-1944. An extraordinary figure for the 1940s. African American workers were also employed in significant numbers, often in skilled positions, defying segregation norms of the era. This democratization of skilled labor sent shockwaves through the old maritime guild system. Workers who had never imagined joining shipbuilding were now crucial to turning out vessels vital to the war effort. The sea of orange helmets and welding goggles in Richmond and other Kaiser yards stood as proof that industrial capacity could be expanded not just by machines, but by human potential, unleashed through opportunity and training. By late 1941, over 10,000 workers were employed at Richmond, fewer than 200 of whom had prior shipyard experience. The transformation of ordinary citizens into highly productive factory workers was accelerating national production rates and challenged assumptions about skill, labor, and industrial organization. Kaiser had not only built a shipyard, but an industrial workforce for a new age. As 1942 progressed, the impact of Kaiser's Industrial Revolution became increasingly visible in the staggering acceleration of Liberty ship production. Shipbuilding times, once measured in months, began to shrink dramatically. The first Liberty ship constructed in Kaiser's Richmond yard took 197 days from keel laying to launch. By the fifth ship, that time had dropped to just 128 days, and by the 10th, only 97 days. Across the yard, workers had adapted astonishingly to the new assembly line techniques and specialized tasks. Each successive vessel emerged from the shipyard faster than the last, driven by increased skills, better coordination, and continual refinements to prefabrication processes. By spring 1942, Liberty ships were routinely completed in an average of just 70 days. Astounding speed compared to traditional shipyards. This rapid pace sent shockwaves through America's established maritime industry, where shipbuilders watched with growing alarm as their traditional craftsmanship was outpaced by what had been dismissed as an unskilled workforce, armed only with welding torches. Amid this acceleration, an intense competition emerged between Kaiser's 7 shipyards located across California, Oregon, and Washington. The Richmond and Portland yards in particular engaged in what became a friendly yet fierce contest to build ships faster than the other. These contests were no secret. Newspapers publicized the constant breaking of speed records like sports scores, fueling worker pride and public enthusiasm. The stakes were high. The faster the ships, the quicker vital supplies could reach war zones. In September 1942, the Oregon shipyard set a new marvel in speed by completing the Liberty ship Joseph N. Teal in just 10 days. The achievement was met with awe and disbelief in naval circles. Recognizing the distraction these stunt builds caused, Vice Admiral Howard Vickery, vice chairman of the Maritime Commission, ordered the competitions to stop. Yet the contests had served their purpose. Kaiser's workers and managers now believed a new standard of extraordinary speed was not only attainable, but expected. The rapid production was made possible through the remarkable industrial choreography of parallel production. Unlike the traditional linear approach where one component's completion depended on another's start, Kaiser's yards worked on the bow, stern, hull sections, and interior compartments simultaneously at different stations. When parts were complete, massive cranes lifted and joined them quickly, compressing assembly from months to days. This approach defied centuries of shipbuilding wisdom, but proved devastatingly effective in wartime. The industry's old guard was forced to confront not only the speed, but the quality of these vessels. Ships emerging from Kaiser's yards were not elegant masterpieces, but they were seaworthy and capable of carrying vital cargoes across hostile oceans. The maritime establishment was beginning to realize that perfection in craftsmanship could no longer stand in the way of production efficiency. The pace of production and the resulting surge in Liberty ship output helped swing the scales in the Allies' favor during the darkest days of the Battle of the Atlantic, where German U-boats aimed to strangle supplies by sinking ships. Kaiser's factories turned out replacements with unprecedented speed and scale. Production statistics were rewriting the mathematics of war. Outproducing losses became the new strategy for victory at sea. November 1942 marked the ultimate test and triumph of Kaiser's radical shipbuilding experiment with the construction of the SS Robert E. Peary. This ship was destined not only to join the growing Liberty fleet, but to serve as a dramatic proof of concept. Could a full-sized cargo vessel be built faster than anyone dared imagine? The challenge arose during an inspection visit by Vice Admiral Emery Land to Richmond Shipyard No. 2, where the progress of Liberty ships had already set impressive speed records. Land's offhand remark, overheard by Chief Engineer Clay Bedford, questioned whether production speeds could truly match those of automobile factories. Bedford took this as a call to action. The plan was bold: build a complete Liberty ship from keel laying to launch in under 10 days, slashing the previous speed record in half. With Admiral Land's cautious approval, Bedford selected hull number 47 for the attempt. The ship's name honored Robert E. Peary, the famous Arctic explorer who had pushed human limits. Now, a new kind of frontier awaited: the industrial frontier. Starting in the earliest hours of November 8th, over 1,000 workers operated in carefully choreographed shifts around the clock. The shipyard's prefabrication strategy reached its peak. Massive sections of the ship had already been fabricated off to the side, fully equipped with hardware, compartments, and machinery. The bow section alone comprised more than 50 individual pieces, ready to be assembled. The stern arrived, complete with the steering gear, propeller shaft, and crew quarters fully outfitted. The engine, a 140-ton triple-expansion steam plant, manufactured by Joshua Hendy Iron Works in Sunnyvale, was mounted and tested before shipment, ready for immediate placement. The shipyard operated like a giant puzzle factory, where all pieces fit precisely for rapid assembly. In just 4 days, 15 hours, and 29 minutes, the Robert E. Peary's hull was completed, engines installed, deckhouses positioned, and cargo holds secured. At 3:30 p.m. on November 12, 1942, the ship slid down the launching rails into San Francisco Bay, amid an awe-filled crowd including naval officials, journalists, and rival shipyard owners. This feat was more than a record. It was a symbolic victory over tradition, skepticism, and assumed limitations. The ship was fully operational, needing only minor final fittings before deployment. Vice Admiral Land, speaking to newsreel cameras, acknowledged the impossible had been achieved, declaring Kaiser's methods had made centuries of shipbuilding wisdom obsolete. The success of SS Robert E. Peary resonated far beyond the Richmond yards. It was proof that mass production principles, applied intelligently and aggressively, could deliver life-saving vessels on an unprecedented scale. The industrial transformation Kaiser ignited would keep vital supply lines open and turn the tide of the global conflict. This moment illuminated the power of innovation, collective effort, and the unyielding human spirit to break barriers. The Robert E. Peary stood as a testament to what ordinary people could achieve when freed from old constraints, united in purpose, and driven by necessity. Its launch was the dawn of a new industrial age, built on speed, scale, and determination. The triumph of the SS Robert E. Peary was not a standalone achievement, but the culmination of a sweeping transformation of American maritime production during World War II. By early 1943, The industrial revolution Kaiser ignited at Richmond had spread to 18 shipyards across the country, reshaping shipbuilding into a highly efficient, standardized, and mass-produced enterprise. Between 1941 and 1945, these yards collectively built 2,710 Liberty ships under Maritime Commission contracts, averaging nearly 2 ships launched every day at peak production. Kaiser's 7 shipyards alone produced 1,490 of these vessels, representing more than a quarter of the nation's wartime shipbuilding output. The efficiency gains were staggering. Construction time plunged from 230 days at the outset to just 42 days on average by mid-1943. The rhythm of wartime shipbuilding was relentless. Factories operated around the clock, employing 3 8-hour shifts that maximized the use of machinery, space, and human labor. Prefabrication techniques continued to improve, with even larger sections assembled off-site and swiftly integrated into the hull. Welding techniques matured, ironing out early challenges such as brittle fracture through better steel specifications and refined practices. Despite initial doubts, the Liberty ships proved remarkably reliable and effective. About 200 were lost to enemy action during the war, a loss rate significantly below pre-war merchant shipping averages. While isolated cases of structural failures occurred, 3 ships famously breaking in half due to brittle fractures, the vast majority sailed safely, validating Kaiser's bold construction approach. Each Liberty ship displaced 14,245 tons when fully loaded and transported as much as 10,800 tons of cargo per voyage, including thousands of jeeps, tanks, and millions of rounds of ammunition, essential lifelines to Allied operations across multiple theaters. Powered by simple and reliable triple-expansion steam engines, the ships traveled at a steady 11 knots, cruising speed adequate for mass convoy movements. Kaiser's relentless focus on efficiency also extended to labor. The unwavering training system produced welders capable of spot welding in as little as 10 days, while crane operators and fitters reached readiness within weeks, a stark contrast to traditional apprenticeships spanning years. This specialization and task division allowed unprecedented productivity and minimized bottlenecks. By mid-1943, Kaiser's yards were not just outproducing traditional shipyards, they were setting new global standards. The maritime establishment was forced to acknowledge that the wartime necessity had shattered preconceived limits on production speed, labor skill, and industrial organization. The Liberty ship program had become a cornerstone of Allied logistics, quietly delivering brute force through industrial might. As steel and welding replaced rivets and hand craftsmanship, America's strategy evolved. Victory would be ensured by outbuilding the enemy, tipping the sea war's mathematical balance decisively in the Allies' favor. Kaiser's vision, once derided, now steered the colossal maritime effort that kept supply lines open, armies fueled, and hope alive across the global conflict. The war at sea was being won not just on the oceans, but within these sprawling shipyards, where innovation, determination, and scale united to reshape industrial history. The rapid expansion of ship production under Kaiser's program generated profound social and economic ripples that went far beyond the metal of Liberty ships and welding torches. Entire communities were transformed by the frenzy of wartime industry, reshaping the American workforce, social fabric, and even healthcare models in extraordinary ways. The city of Richmond, California, epitomized this transformation. Between 1940 and 1943, the population surged from 23,000 to over 100,000, fueled almost entirely by shipyard employment. The influx of workers, women, minorities, and unskilled laborers from across the country created a vibrant, if chaotic, boomtown atmosphere. New housing developments, schools, and services sprang up almost overnight to support the swelling workforce. Kaiser's impact extended beyond employment. Recognizing the health risks and challenges of his vast industrial operation, Kaiser partnered with physician Sidney Garfield to establish prepaid healthcare programs aimed at keeping workers healthy and productive. This initiative evolved into Kaiser Permanente, one of America's largest and most enduring health maintenance organizations. The shipyard model of integrated preventive healthcare served millions and set new standards in American medicine. Socially, the wartime shipyards were remarkable for breaking long-standing barriers. Women, who constituted over a quarter of Richmond's workforce by mid-1944, found new skills and independence in welding, fitting, and operating cranes. This shift altered perceptions of gender roles within labor and laid groundwork for future movements toward workplace equality. African American workers also gained unprecedented access to skilled positions, from welding to supervisory roles, challenging segregation norms prevalent in 1940s America. Although discrimination persisted, the integrated environment of the shipyards pushed society gradually toward greater inclusion and opportunity. The democratization of skilled labor created lasting effects on the nation's industrial culture. Thousands who had been excluded from skilled work learned trades rapidly and entered professions previously closed to them. The war effort became a powerful engine for social change, illustrating the potential of opportunity combined with training. Post-war, many former shipyard workers carried their newfound skills and confidence into peacetime careers, fueling America's post-war economic boom. The Liberty Ship program had not only produced vessels but also reshaped the American workforce and society in ways that resonated for decades. The ripple effects extended to entire regions. Kaiser's steel production facilities, built to supply his shipyards, helped establish California as a major steel producer for the first time. New cities like Vanport, Oregon, emerged as industrial hubs. These rapid industrial expansions demonstrated how concentrated investment and innovative management could reinvent regional economies almost overnight. Thus, the shipyards were more than factories. They were social laboratories and engines of change, setting precedents for labor inclusion, community development, and healthcare innovation. The legacy of Kaiser's wartime workforce was measured not only by tons of steel, but by lives transformed and barriers broken in the crucible of necessity. The end of World War II brought uncertainty to the wartime shipbuilding boom Kaiser had ignited. As victory celebrations swept the globe and hostilities ceased, many predicted a collapse of the massive shipbuilding effort, and indeed, production slowed dramatically. Liberty Ship construction ended in September 1945, and Kaiser's workforce shrank from nearly 200,000 to under 20,000 within months. The Richmond shipyards, once bustling centers of innovation and industry, fell largely silent by 1946. Yet the legacy of Kaiser's transformation endured far beyond wartime necessity. The technologies, methods, and organizational principles developed in the crucible of emergency became the foundation of modern shipbuilding worldwide. Prefabrication, modular construction, and welded assembly replaced traditional methods globally, providing a blueprint for post-war industrial growth. Rebuilding efforts in Japan and South Korea, devastated by war but poised for industrial resurgence, drew directly on Kaiser's wartime innovations. Massive shipbuilding facilities in Ulsan and Nagasaki emerged as direct descendants of Kaiser's prefabrication strategies and welding techniques. These yards would dominate global ship construction for decades, competing with and often surpassing traditional Western shipbuilders. Kaiser's influence extended well beyond shipyards. The methods pioneered in wartime steel fabrication found applications in structural steel construction, petroleum refining equipment, and pressure vessel manufacturing. Prefabrication approaches revolutionized bridge building, industrial facilities, and even housing construction by allowing faster, more efficient assembly. Organizational lessons from Kaiser's yards. The focus on parallel production, simplified specifications, and rapid specialized training reshaped operations management and industrial engineering education. His transformation of industrial capacity from fixed to rapidly scalable became a foundational example in global manufacturing strategy. The story of Liberty ships also provided a powerful case study in rapid capability development. Harvard's Michael Porter later analyzed how Kaiser's approach demonstrated that seemingly fixed industrial limits could be overcome through innovation and strategic organization. This lesson has enduring relevance for industries facing disruption and rapid change. Kaiser's wartime revolution challenged entrenched assumptions about skill, scale, and capacity. His outsider status and willingness to discard tradition allowed him to envision production systems that experts doubted possible. The impact of this mindset persists, inspiring managers and engineers to rethink what industrial progress demands and how quickly it can be achieved under pressure. Though, the Liberty ships themselves mostly vanished, scrapped or resting quietly beneath the waves, the industrial revolution they embodied remains central to modern manufacturing. Kaiser's breakthroughs transcend geography or industry. They embody the power of necessity-driven innovation and human organization to change what is possible, forever altering the course of maritime construction and industrial history. Behind the steel hulls and welding sparks of Kaiser's shipyards were countless human stories. Ordinary men and women whose lives and aspirations shaped the success of the Liberty Ship program. These workers came from diverse backgrounds, each carrying hopes, challenges, and the determination to contribute to the war effort in whatever way they could. Many women who entered the shipyards brought no prior industrial experience, but quickly mastered welding, riveting, and fitting tasks that once belonged exclusively to men. Their stories revealed resilience, camaraderie, and pride in shattering gender norms. They donned helmets and goggles, learned to wield torches, and took on roles from welders to crane operators, forever changing societal views on women's capabilities. Minority workers, including African Americans, similarly broke barriers. In a segregated America, Kaiser's shipyards provided some of the few opportunities for minorities to access skilled labor and supervisory roles. Though discrimination persisted, the integrated workplace fostered new possibilities and laid groundwork for future civil rights advances. Personal accounts from the yards reveal a blend of challenge and celebration. Workers endured grueling shifts, often in noisy, dangerous conditions, yet found moments of joy in shared meals, holiday celebrations, and music. One notable example was the Christmas of 1943, when Richmond shipyards stayed open, but managed to provide turkey dinners, carolers, and community festivities for the workforce, efforts to honor sacrifices and boost morale amid relentless production demands. Stories of innovation and initiative abounded. Workers developed clever solutions to assembly problems, adapted to new welding techniques, and supported each other through rapid learning curves. The shipyards became laboratories of industrial teamwork and human endurance. These narratives underline a profound truth. The Liberty Ship program's success rested not just on machinery or blueprints, but on people, ordinary individuals thrust into extraordinary roles. Their perseverance and adaptability embodied the industrial spirit Kaiser sought to unlock. Decades later, many of these workers recounted their experiences with pride and gratitude. The skills and confidence gained in the yards shaped their post-war lives, fueling America's economic boom and social transformation. Ultimately, the story of Kaiser's shipyards is as much about human courage and community as it is about steel and speed. It stands testament to how necessity, opportunity, and collective effort can empower ordinary people to achieve extraordinary results in the face of daunting challenges. The legacy of Henry Kaiser's Liberty Ship program extends far beyond the vessels themselves. It is a story about redefining industrial possibility and achieving what once seemed impossible. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic outcome with enduring insight. The war across vast ocean distances was won as much by American shipyards as by valor on distant beaches. Japanese planners had assumed that by sinking enough ships, Allied supply lines would collapse, forcing negotiations or defeat. What they failed to anticipate was the unmatched speed and scale of American production led by Kaiser. By 1944, the United States was replacing losses faster than the enemy could inflict them, building 3 ships daily where the Axis sank 2. The mathematics of attrition favored industrial capacity, turning the tide of the war. The SS Robert E. Peary and the 1,490 Liberty ships built by Kaiser's yards are symbols of a transformation that transcended maritime history. They embodied a fundamental shift from craft-based production to systematized mass manufacturing, empowered by specialization, prefabrication, and welding. This shift challenged convention, broke through assumed limits, and democratized skilled labor. Kaiser's greatest achievement lies not merely in ships produced, but in altering how industries conceive of production, work, and possibility. The lessons from Richmond's shipyards ripple through modern manufacturing, construction, healthcare, and organizational theory. They demonstrate that ingenuity and determination, paired with bold organization and rapid training, can overcome barriers that expertise alone cannot. In closing, the story of Liberty ships is a testament to the potential locked within ordinary people when given the opportunity, training, and belief that they can meet challenges long regarded as impossible. It reminds us that tradition, while valuable, is not destiny, that progress demands questioning limits and daring to reimagine what human effort can achieve. The Liberty ships carried more than cargo across oceans. They carried proof that human creativity, collaboration, and courage can transform the impossible into reality. Kaiser's legacy is carved not just in steel, but in the transformed understanding of what dedicated people can accomplish when freed from constraints and united by a common purpose. From the first contract, signed in December 1940, through the record-setting launch of the Robert E. Peary in November 1942, to the final ship delivered in 1945, this industrial revolution reshaped history. The ships may have mostly vanished, but the revolution they sparked sails on, beckoning every generation to challenge, innovate, and build faster than the limits imposed by yesterday's wisdom.